Hey all, welcome back to Radical Slice. Eric here. So I promised you state machines, and I'm gonna deliver big time. So let's just jump right in and talk about how we're gonna handle player state. In order to explain how I'm thinking of the state machine around combat, so I want to have, as I mentioned, some sort of like anticipatory states for each of the combat animations. Let me just we'll draw some boxes here. Give me a minute. Let's have a look at what I have in mind here. So the one thing that we do have working is the player has some sort of like initial state, or we'll consider this also the standing state. And make a note about that. Stand here. And when the player touches the left or right arrow keys, which we'll just make a note of that here, like that, the little Kung Fu man will start walking. And then if we release those arrow keys, we'll go back to our standing state. Let's say like no button, no B. If the player touches the circle button here, the Kung Fu man will do his sort of anticipatory punching state, which is the sprite kind of on the left up here, where it's winding up. And then after a few frames, it'll move into the full-on punch state, which is the state on the left here, where he's got his mouth open and he's shouting. So this will be sort of like time-based. We'll call this like end frames to indicate that we're waiting for something to make this state change. And then after some other number of frames, we're going to move back to the standing state, like this. Like that, right? Because we don't want the punch to just like last forever. We just want it to, he'll be punching for some frames, and then once the punch is done, we'll go back to this like initial state. So the kick will be very similar. So the only difference would be that to fire the kick, it would be the X button. After end frames, we'll go here. Let's call it NFR. And then again, after some frames, we'll go back to the init state. Not bad. The only thing we don't have in here is the duck stuff, but you can imagine the duck thing will look a lot similar to this. It'll just be like, rather than the init state, it'll just be like a held ducking state or crouching. I guess I should say crouching so that we don't get confused with like the waterfowl of ducks. The guy's not going to turn into a duck in this game. Yeah, so like rather than the init standing state, the init would be, you know, the crouching state, and the punch and kick antics would be the same. All right, now, by the way, I hope you enjoyed how much I've leveled up my MS Paint game for the state machine since the last video series. I certainly think I've come a long way. Let me see if I can figure out how to program this stuff in, because I'm not sure how, in particular, the triggers around like the animation timings, like this bit, I'm a little bit worried about how I'm going to structure that in code. So let me work on that for a bit, and then I will check back in when I have a direction. I've made quite a few changes, so let me walk through them now. I gave the player a state to keep track of where we are in our state diagram, and I, in the comments, listed all the states that we talked about just for my own sanity, basically. So there's the stand, walk, the punching antic, the kicking antic, then the punch and kick. And I did some refactoring in the update function. When I was working on my previous couple of titles, I noticed that if you have an entity with a lot of different states, the update function can get kind of unwieldy because you're always like, oh, if the state is this, then do this, but if not, then do this. And so I tried to just encapsulate the logic for each, the update logic for each state in its own function. So if the player is standing, we'll call update player stand. If they're walking, we'll call update player walk, etc., etc. I'm hoping this will make things a little bit easier because it sort of just puts all the logic for each state into one place. Now, I also go up here, had to add this state timer thing because as we talked about in our diagram, there are certain state transitions that are going to happen after some, I used frames here, but actually I'm using actual clock, like wall clock time, not frames. But after a certain amount of time, we're going to move from one state to the other. And we do already have the frame wait, which is sort of a similar idea, this frame timer. I should probably just change this to frame T for consistency, but we have this frame timer that is controlling how, for example, how quickly we cycle through the walk frames. But the reason I can't really use this, or I don't want to use this, is because the timing of states is sort of orthogonal or independent of the timing of frames, right? So we may only have one state, like walking, that we need to track that has multiple frames to it, right? And so it's easier for me to think about this if we have two different timers operating independently. Even though that seems like it's more complexity, in the long run, I think it's better to decouple the updating of the frame from the updating of the state. So now if we go down here-ish, here are a couple of the update functions. So I pulled the previous logic from our big update function into this update p stand, update player stand, where we're just checking for button presses, and the update player walk, where we're just checking for no button presses. And if there's nothing being pressed, we'll reset to the stand state. If we get a button press for the punch or the kick, we do a few things. We are going to set the player's state. We're going to set the timer for how long we want them to be in that state. And I'm using a huge value here so that we can debug, so we can actually see that it's working. This is a full second, which for a punch or an attack antic, you wouldn't want to set a full second. But let's just say that's what we're doing. So we're going to set a full second. We're going to change the frames so that we know which frames to draw. And we're going to reset the since last state timer so that we know how we can track like how long to keep the player in the state. And that's the same for punch and kick. This logic, it looks like it's going to be pretty repetitive. Like you can kind of see here, the only difference is like the state and the frames. So I may pull this out into a separate function to save some tokens later. But once the player is in this punch antic state, I'll pop down here. We're doing the same timer check. So we're passing in the delta t, the amount of time that's passed since the last frame. And we're keeping track of how much time has passed. And then once that much time has elapsed, we'll go back to the standing state and we'll reset our frames. So what we would expect to see in this case is we're going to push either the punch or the kick button. The player will do that movement for a second and it'll be drawn that way for a second. And then it'll just go back to the standing state. So we're not actually doing the full attack yet. It's sort of like a half measure. And in fact, that is what we see. So walking still works, although, oh, there we go, yeah. So walking still works, which is good. And if we press punch, he kind of like winds up the punch, but he doesn't do the full thing. And then after a second, he goes back to standing. Same thing for kick. We press kick, he kind of winds up. And I'm not drawing the full sprite yet, but he kind of winds up and he gets ready to kick, but he doesn't do it yet. So the next thing I'm going to do is add in the full punch and kick states. And I think I squashed all the bugs that I was having, and I filled out the update p punch and update p kick things. And similar here, we're just kind of waiting for the timer to tick down before we go back to the standing state. One thing I guess that's noteworthy is I was playing with the timings between moving between the punch antic and the punch and the kick antic and the kick. I kind of want the kick to be a little bit slower and more deliberate. So for the punch, I'm only waiting for 0.05 of a second, whereas for the kick, I'm waiting for a full 1/10 of a second. So you'll see like it the punch is a little bit snappier than the kick. Same thing for the actual thing itself. The punch only lasts, like the full, like fully extended punch is only for 15 hundredths of a second, whereas the full kick extension is 3/10 of a second, so it's a lot slower. So pop over here real quick. You can kind of see he's doing the full thing, and the punch antic is like quite quick, so it might be difficult to see, but it's definitely in there. And then the kick is like a little bit slower. I might actually speed that up a bit. It's a little bit chunky. And you can hold the button down right now and just like machine gun punch guys. I don't know if I'm going to keep that or not, but it is kind of cool for now. Of course, as you can see, the punch fist and the kick foot are not being drawn at the moment, so I'm going to go ahead and get those added in now. One of those brief amusing moments. I did get the punch working pretty well, and then I was trying to line up the sprites for the kick, and yeah, his leg just falls off, so I thought I would share that. Also, I don't have the flipped version working correctly, so progress. Give me another minute. All right, so as you can see, we now have the fist being drawn. I tweaked the timings a little bit on the state transitions to make the kick a little bit snappier, as I expected I was going to want to do. Pretty cool. It works this way too. His leg doesn't fall off anymore, which is a positive. So I'm pretty stoked about that. I think I still have to do the crouching bits, and I have to do collision with the enemy. So collision is going to be interesting. Right now, jump back to the terminal here. The only sort of mention of the punch and the kick bits is in here. In my draw function, I'm just looking to see if the player is in a state where we need to draw an additional sprite, and I'm drawing it. But the fist and the leg that are involved in the punch and the kick are going to require collision so that we can actually like hit dudes that come at us. And so I'm going to have to probably have some sort of separate entity to represent the punch or the kick, or at least give some way for the game to know where the fist and leg are. So I'll probably spend a little bit of time sorting that out next. What I sort of have in mind for the collision is, I guess it's probably easier to contrast it with how I've done it before now. Let's start with this. I think it's the right brush, yeah. What I've done until now is I've had this sort of like sprite type. It's awful. Sprite. I've had this sort of sprite type, and as part of this, I would have like size X and size Y values. So if the sprite was 8x8, it would be 8x8. If it was 6x6, it would be whatever. And kind of like a height and width. And also I would have, you know, pos X for the X position and pos Y for the Y position. And what I would do is I would sort of like, I would have like a bounding box collision function that would take two of these sprite objects and sort of use these, you know, size and pos variables to see if S1, sprite 1 and sprite 2 overlapped. I'm thinking of doing something a little bit different this time. So let me clear this out and start over. What I think I'd like to do instead is have some sort of method or function, if you will, on the player object. Something like, I don't know, get BB. And really, because when we're doing collision, at least for bounding box collision, all we really care about is, here's our player inside this box. When we're checking for collision, the only things we really care about are these four coordinates, right? Having the collision algorithm that's probably running in main, like try to figure out where these values should be based on player size and stuff, I found that to be like pretty unwieldy in previous titles. So I want main to only get these coordinates, and I want the player to sort of own where they are, right? So if we decide to change something, let me redraw this. So if for whatever reason we want to reduce the size of the player's collision box to be like somewhere around here instead, we don't have to like do any hacky stuff in main to make that happen. We'll just have this get BB function in player just return like a smaller box. So that main is basically agnostic to the size and dimensions of the player. All main is going to care about is like this rectangle, right? So we'll probably need a couple of different functions here. We'll basically need this player.getBB function for the player collision. Player's collision box. And this is to check if there are any enemies bouncing off the player, and we need to, deduct player health. The other thing would probably be player.get attack BB. And this will be something similar, right? So if we have our player, and let's say, let's see if we can draw this stick figure doing a punch move. I don't know if I can really do this. Sort of like got a bent knee, and one arm is out here, and one arm is like this. Hey, that's not bad. So in the punch case, we need to check for collision with enemies. Yar. With enemies based on this bounding box. Right, so these two boxes, this player.getBB and player.getAttackBB, are going to be treated differently in the collision code, right? If it's player's box, we want the player to take damage, but if it's the attack box, we want the enemy to take damage. So, and again, main only needs to really care about like where the dimensions are. It shouldn't care about if it's punching or kicking or any of the other stuff. It's basically just going to want to compare the player's fist box with the enemy's like collision box, like that. So that's what I'm thinking of. I'm going to write up these methods, and initially I'm going to use them to draw the collision boxes to the screen to see if they're kind of where I want them to be. I got the collision boxes drawn in a way that I think is going to work out. Let me kind of explain. Actually, let me show you what it looks like first. So you can see around our hero, we've got this green box, which represents the player's bounding box. So any enemy that would like collide with that rectangle would cause the player to take some damage. Similarly, when we attack, you'll see these little pink boxes kind of overdrawn on the player's fist and legs, and those would represent, obviously, like if the enemy hit the pink boxes, they would take damage. And they're aligned on the left and right, which took a little bit of tweaking, as you may have noticed if I decided to fast forward through the coding process. So let me kind of explain what the heck is going on here. So I did more or less what I planned to do. I defined, this is the player's draw function, by the way. So in order to test that my bounding boxes made sense, I just wanted to draw them to the screen first. So as you can see here, we've got this P is the player, get bounding box function, and we're returning, you know, the upper left and lower right coordinates for that. And I'm just drawing a green rectangle over that. So that's the green part that you see. Then a little bit further down, this is a little bit more interesting. I defined this get attack BB function, which is going to return the bounding boxes for the fist or the leg, depending on if the player is kicking or punching. So this function not only returns the upper left in the x2 and y2, and the lower right in x3 and y3, it also returns this fifth value called check me, and I'll explain that in a minute. But if check me is true, then that's when we're going to draw the pink rectangle to represent the bounding box of the fist or the leg. Now, this is up here. The reason I'm returning a fifth value, this check me value, is because the player might not always be attacking, and so this function might not always return coordinates, right? It might not always be, we might not always want main to check for the thing because the kick or the punch, or I guess the fist or the leg might not even be there. So the way I got around that is to just, if the player's state is punching, then we're returning some different bounding boxes, whether the player's facing left or right. And we're returning true for the first value, say, to tell the collision algorithm, or in this case, the draw function, like, yeah, I definitely want you to draw here. There is some attack going on. Same thing for kick. But if the player is not in a punching or in a kicking state, then we simply return false. And that's sort of acting as a flag for, in this case, the draw function, but eventually for the collision code, to be like, no, there is nothing here to see. There is no bounding box. Don't worry about it. So that was, and it's kind of a kludgy solution, like in a language with a little bit more expressiveness. You might want to return like an optional value or a maybe value here. But we're working with what we've got. So I've decided to just return a Boolean flag as the first value to the function so that we know how to handle the return values here. Another way to approach this would have been to say we just return nil and then check x2 to see if it was nil or if it was an integer. But I thought that this was a little bit more explicit and will cause me less mental suffering later if I have something like an explicit flag for check me. So that's how we draw those rectangles on the screen. And I think this will probably, by defining these player.getBB and getAttackBB functions, this will probably save me from defining the leg and the fist as separate entities later. Like I had in my head that I was going to have like the player have like a fist property or a leg property, and that would have its own like collision related code. But I think just by like defining this method, I've sort of wrapped it in such a way that the collision code can just call it, see if check me is set, and then do the bounding box collision based on the values returned there. So I think this is probably a pretty clean solution for dealing with the situation where sometimes we're going to want to check the collision, but sometimes we won't. I've talked about this or similar topics anyway in previous videos as well, but I like to try to keep my main game loop pretty simple and, you know, just have it calling sort of the update functions for the various game entities like the player or the baddie, some sort of entity manager or whatever. I don't really like having main manage the baddies directly, like basically main having to check each individual baddie for collision. That just like gets really messy, and especially when you're switching in between levels and different sets of baddies, it can just make your main like really convoluted. You just have a lot of code in your main game loop and it gets harder to read. So generally what I like to do is I like to usually introduce some sort of abstraction between the main game loop and the baddies. So main only kind of talks to like this baddie manager entity and says, so it'll say like, hey, baddie manager, can you like do some collision for me? Or hey, baddie manager, can you spawn some dudes in this level for me? And then the baddie manager is kind of the thing that as the name implies, manages the various entities. In this case, they're bad guys. I think this kind of like separation makes things a lot easier. So baddie manager might expose some methods like, you know, collision or spawn or something like that. So I think these are the kinds of methods that we're going to give to main and just let main call them based on whatever the level is or whatever point in the game loop we're at. So I've made some pretty good progress on the baddie spawning stuff, and I wanted to talk a little bit more about the spawn method in particular. So let me kind of make some notes here. So if you've played the original Kung Fu or Spartan X on the NES, and if you haven't, I recommend you do because it's actually a pretty cool little game. You'll know that the way that baddies kind of spawn in is like in groups, and in the initial level, you know, they may come in one at a time, and then in later levels they'll spawn in groups of like two or three. And so what I was thinking is, right now we don't have any sort of concept of levels, so we'll just use main as a replacement for any sort of like level management or whatever. But when main wants to talk to the baddie manager, which we'll abbreviate as BMGR, whenever main wants to like say, hey, like spawn a guy or spawn some guys, spawn baddies. I was trying to think about like what sort of spawn patterns main would be interested in, right? And in general, main's going to want to request a couple of things from the baddie manager. It's going to want to say like, hey, spawn in a guy on the left of the screen or on the right of the screen. And it's going to say, hey, I want one guy, or hey, I want three guys, to kind of spawn in groups. And so if I'm thinking sort of, and this is kind of a little bit getting into the weeds of the code, so I won't spend too much time on it, but really if we think about the spawn method, that the baddie manager is going to expose here, it's going to take a couple of things. It's going to take the number of guys to spawn is like the first argument. And then the second argument would be like the direction that they're facing or the side of the screen. And so as long as the baddie manager is giving us the capability to spawn arbitrarily many number of baddies on any side of the screen, of which there are two, but still, as long as we can expose this kind of interface, we should be able to design levels, which would probably be, we'll probably have like some sort of level stuff happening over here. This interface for spawn should cover any use cases we want. The only other thing that we may have to add later would probably be like the type of baddies. So later on, you know, when we add in like the projectile throwing guys, or maybe even the boss, we may want to change this interface slightly. But for now, I think just the number of baddies on the side of the screen should be enough. So let me kind of step through the code briefly too. Okay, so no surprises, I think, for the update and draw functions. We just have this baddies table inside the baddie manager, and we're just going to loop over it and call the update and draw on each individual baddie. So no surprises, I think. I haven't implemented the collision functionality yet. We'll get to that later. The spawn stuff is where things get interesting. So the first argument is just the baddie manager itself, so we can sort of ignore that. But then we, as I was explaining before, we'll have like the number of baddies to spawn and the direction that they're going to be facing, which corresponds to the side of the screen that they'll spawn on. And then we sort of loop from 1 to whatever that number is, and we add in baddies to our baddies table based on that. Now the interesting thing is, and actually maybe we should jump back to Paint to explain this. When we're spawning guys in, if let me draw like a thing for the screen here. Oops. You know, as we're spawning guys in, we want to start them, you know, in either just off the left side of the screen or just off the right side of the screen, like this. But if we're going to spawn them in groups, we need to sort of gradually increment the starting X position so that they don't overlap, right? So that they kind of spawn in like this. Similarly, if they're on this side of the screen, we have to kind of increment in this direction and sort of spawn them like this, so that they're positioned correctly when they start appearing on the screen in batches. And so that's what I'm doing here. You can see that I have this start X variable, And for every baddie that I spawn in, I'm just incrementing or decrementing that based on the direction of the side of the screen that the baddies are going to spawn in on. There's not a lot of interesting stuff going on in this new baddie function. I'm just setting some initial values for it, setting up the animation frames. It's all very similar to what I did for the player. So when I go to main, just to test this during the init call, as I create the player and then I'm just like spawning in a baddie really quick just to see that I wanted to test that the baddie manager was working, that they were drawing to the screen correctly, and all that jazz. So if we do that, we can see. There we go. There goes our guy. You can see the baddies are trees in this game. I may have forgotten to mention that. So here's my like tree guys. A very quickly slapped together walk cycle of 2 frames. So yeah, our baddie spawns on a single baddie spawns on the left side of the screen. So we can change the direction that this spawns in. So just in the upper left, I'll change from 1 to 0, and this should spawn on the right side. There we go, and he faces the correct direction, and everything is cool. Similarly, if I wanted to spawn 2 guys from the left, I can change the arguments to the initial spawn function, and I'll get 2 guys, and their positions are offset as we would expect. And we can just like go nuts with this, right? Let's have 3 guys spawn in from the right. And there they go, all right? So everything seems to be working pretty well. I'm pretty stoked about how easy that is to just spawn in arbitrary numbers of evil trees. Now I think the time has come to do a little bit of the collision work. Okay, let's wrap this one up here. And next time we're gonna dive into the old Kung Fu hug of death. So look forward to that one. But yeah, thank you for your time. Thank you for watching. I hope you learned some stuff. I hope this was compelling. If you enjoyed yourself, yeah, click a button somewhere. Hopefully one of the good ones, but you know, whatever. I'm pretty sure the algorithm recognizes any interaction, honestly. But yeah, thanks again for your time, and I'll catch you again soon. Bye for now.